DevOps in a pandemic. So working at DDI, yeah, we get to play some cool tech. So who's had the unfortunate experience of coming to a COVID clinic? Hopefully not recently. So, otherwise, yeah, back of the room, please. So, as you can see there, the nurses have got iPads, and that's what I want to talk about today. I'm not an iPad salesman, but specifically the software on there. So, as I was saying before, I work for DDI, so I'm privileged to be there now for a long time. I've got about 6 staff to work with me, and we get to invent stuff. We get to solve healthcare problems, which is great. It's very, it's a good feeling. So, in early March last year, 11:30 a.m. in fact, my boss grabbed me and said, "Oh, can you come to the conference room?" And what he told me was that we're opening a COVID clinic, the first one I think in WA at the time, at Royal Perth on the Tuesday. And they'd come up with a paper-based form for each patient. So, demographics, where they travelled, all the sort of things we knew at the time we were concerned about, symptoms, etc. And it was a paper-based form, and they said, could we digitise it before the clinic opened? And so, yeah, shit deal. But anyway, so they managed to get a vendor in, Telstra Purple, I think they're in the crowd somewhere, so to give us a hand. And the idea was to reduce or increase infection control, because moving paper around between people in a pandemic, if we can minimise that, that's a good thing. So with the guys from TP, we set about building it across the weekend. Now, one of the things I asked my boss at the time was, because we didn't know anything, the question was, how much volume are we going to expect? How many people are we going to test and at what pace? And his answer to me was, I'll never forget, was just assume everyone in Western Australia gets tested twice. So I got onto Google, 2.5 million people times 2, 5 million. Now, we have data warehouses with hundreds of millions of rows, so not particularly a number I'm scared of, but it was more in what space of time. So anyway, we spent the weekend, the Telstra guys went home or back to their office, worked the weekend, we were on Teams, phone calls, we only got to meet them for an hour, and off we went. We showed them how our place worked, and off they went. So we had to teach them about healthcare, how, what systolic was, what diastolic blood pressure is, so on and so forth. But 3 days later, so late Monday night, around 11 p.m, we got into production, after going through dev test, UAT, and everything else, and testing, of course. And then Tuesday morning, 8 a.m, the clinic opened. And everything worked, thank God. So, and at that point, or across that time, we started to learn a new term, essential worker. So I never thought of myself as essential worker. I work in a hospital, yes, but I think of the nurses and the doctors and the people who are actually touching patients as essential workers, where we're just paper jockeys fixing printers. So, so that became important to us. We couldn't work from home. We had to be on campus with the staff. With the healthcare workers. And yes, that's really how the COVID assessment form, as we came to call it, entered our world. So today what I want to talk about is how we did it, quickly over the next 20 odd minutes, about how we used DevOps, how we implemented that, and how we got a reliable pathway to production. Also under the hood, so what kind of architecture underpinned it, what we used to facilitate those rapid deployments, and finally some lessons learned, a bit of people, a bit of tech. So hopefully there's something for everyone. So the first one is DevOps. So DevOps for us is software development and system operations together. So we're a fairly small team. We've got about 6 developers, as I said before, 2 sysadmins that sort of help us out a bit too, but they've got their own problems. But anyway, so between all of us, we run this infrastructure and develop software and release it. So we use Azure, we're a Microsoft shop. Charles is here somewhere, I think. So for us, it's a logical extension to go into Azure, easy for us to set up. We have a close relationship with them, which was very useful for us in deploying. And we have a guy called Alex. I won't give you his surname, but anyway, Alex is our DevOps guy. That's his sole purpose in life. He actually likes this job. He used to be a developer, but he's fantastic at DevOps. And if we have a problem, if we want to automate a piece, if we have to solve something around getting code deployed, he's our man. So without him, we couldn't get this stuff into prod, and that was one problem we could farm away, and he's done fantastically at it. And as I just went through before, we needed, and we wanted automated, the safe, reliable, robust, secure, repeatable steps, and automate as much as possible. I've heard people say it before, but that's really where you get your reliability, and having a guy like Alex is really helpful. And And as I said before, the admins are busy. We've got plenty of on-prem stuff they've got to deal with. So for us, the more we could automate, take admins out of the equation, not that we don't trust them, but we just don't want them around. Backing up databases, deploying code, we can script it, then we don't need them. So less problem for us, less hassle for them, which was great. So how do we actually do it? How did we, the technical side of things? So again, being a Microsoft shop, Azure DevOps is obviously where we go. So Visual Studio is what we use, .NET Core for our microservices, and React for our front end. So that was our weapons of choice. So just like everybody else in Azure, we use the repos up there. We've got 2 repos, one for our microservices, one for our front ends with build pipelines. All of that's automated, and release pipelines pushing out to our environments. So as I was saying before, version control, build and release is through there. We have a concept that we call gated check-ins, which I think is a throwback term from TFS. And what that basically means is no code can enter our repos unless it builds successfully. It stops having crap code. So we always know when we pull code, it's going to build, and we don't have to go looking for the last idiot that touched it. So the other bit was that we made infrastructure tasks part of the process. That goes back to the safe and reliable. If we can script it, if we have to do it more than once, we automate it. We write code, we get something, we pinch it off the internet, wherever, to make it part of the pipeline. So where it started out just deploying a piece of code, now we have about 8 or 9 steps to do a variety of things for us. Flushing readers caches, deploying databases, varying database sizes, checking security, turning on auditing, all those things we need to do, because the Auditor General kill us, are in there. And we have approval gates in QA and production for the same reason. Idiots don't deploy to prods, except I did last week by accident. So they're good processes and they're deliberately there. So only 1 or 2 people can deploy into those environments quite deliberately so we don't blow anything up. And the net result was, from March to September last year, we got 368 releases into production. So I did the maths, I think it's around 3 or 4 a day. So it doesn't sound so good then, but it sounds cooler, I think, that way. So under the hood, what's the architecture? So as I said before, microservices. So I know there's a monolithic talk later, which I will be listening to. It's not monolithic. It's not one large chunk of code. It's a lot of little chunks of code. It solves, each microservice solves an individual problem. So if you can logically group it as a process or as a task, then that's really where you shape them. They're small, independent, loosely coupled. They can be deployed independently. So this is a massive plus, and I absolutely love this, but I think it scares my boss, is we can go from dev to prod if the microservice is not consumed by anyone, because we don't impact anybody. So as fast as the developer can code it, as fast as we can test it, as fast as we can get ready, we can go to prod. So sometimes the same day, sometimes as long as needed, it's great, and we don't impact anybody else, which is a fantastic bit of that. They're separate code bases, which goes back to the deployed independently. Because they live by themselves, you can compile, deploy, and not worry about anyone else, which is a fantastic feature. Well-defined interfaces. So it's an argument we have in our office, not an argument, but a rule. It's called don't break the contract. If you do break the contract, well, we don't sack you, we just laugh at you, I'll tell you off. But we do extend the contract because we hate versioning. So if we add extra things to the contract, extra field in a JSON document, as the manager, I get to deem that acceptable, but we don't take things away from the contract because that would break code. But well-defined interfaces are very important, and not breaking the contract is very important, very valuable. And if you do break the contract, release a new version in a separate URL. So you can see from the diagram pinched off the net, that really explains microservices in a nutshell. You can see as an API gateway. So if you think of the client as the app, the React front end, whatever, we have like an orchestrator microservice, and that coordinates multiple microservice calls to return one document to the front end. So the front end's not making 20 calls, it makes one, but in the back we do all the orchestration and then hand off one final document exactly as the UI boys need it or the front end needs it. So what are the pluses of microservice for us? Agility, as I said before, it's high-speed deploys. And we can deploy at any speed we want. As fast as a developer can be is as fast as you can deploy the code. It's worked really well for us. Single business domain, I said before. So again, in a healthcare setting, some of the logical examples you can think of is, say, patient lookup. So you may have a microservice that facilitates the ability to search for patients. So we've got about 4.5 million patients recorded in public health. So you want one microservice to do that. You may have another one for patient locations. If they're currently admitted, where are they in hospital? So that's a smaller data set, and that's a separate microservice for us. Test results, another common example. Patient documents, think discharge documents, radiology, theatre reports, that sort of stuff. And some of the more simple things like, looking up a staff member's name, all those services. We have about 43 in production. So, yeah, each one is a single task or a single business domain. The other bit of it is I made it competitive, so because that's who I am. The competition is how fast can you deploy a piece of code into dev and built without errors. So I've got the record at 14 minutes and about 50 odd seconds. No one's beaten me yet, I really hope they do, and it just makes it fun. Also, we have naming rights on that, so we've got some pretty interesting names on our servers. The other bit of it for us, for microservices, was fault isolation. So we use PRTG, you may be familiar with. It's our monitoring app. We use it for on-prem and Azure. We have some around 1,000 sensors, and I heard in the previous talk around site reliability and the fault finding, the post-incident review, or the post-mortem is what we call it. And so for me, one of my big rules is if something breaks, why did our monitoring miss it? So that's where we use PRTG, and if we learn a lesson, we go, all right, well, let's get another sensor in there, let's write something to make sure we can capture that event, so it's very valuable for us. And that's how PRTG ended up with about 1,000 sensors. We monitor everything, rabbit queues, elastic clusters, database sizes, all sorts of things. And so that's been very, very valuable for us. And in the microservice space, as part of our architecture, we created what we call a health check endpoint. And that's something we made that is generic to every microservice. And what that means is for PRTG, or it's just an endpoint, is you can query it, and it's basically saying to the microservice, are you okay? And so behind that call could be anything. It could be a database test, it could be, can I write to disk? It doesn't really matter, and PRTG doesn't care. What it cares is you come back and say, yes, I'm okay. Because if you're not, error goes up and we can investigate. So for us, that's a very, very big valuable thing, and especially when you've got a large amount of sensors, that's really our to-do list. And as I said before, the sysadmins are busy, they watch this screen, and that's the effective of their BAU. The example I gave before around scalability, so that's a really good example of the microservice capability of scalability. Is patient lookup for us is 4.5 million records. And in the early days of COVID, one of the things they wanted to do was, a lot of patients coming through, you want to be, instead of asking every patient or every person visiting the clinic, what's your name, what's your address, what's your Medicare, kind of blah, 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 and typing all that out and all the error rate, we used to say that we just had them search, do a lookup. And so the microservice we provided was a demographic one or patient lookup. And as I was saying before, 4.5 million rows hitting SQL Server on an unknown scale, we had to make sure that we could give more compute, more resource to the demographics microservice as opposed to the patient location one I was talking about before, which is 10,000 records, so very small in comparison. So we could give more compute on the SQL side, on the compute side. So demographics, instead of being 1 or 2 seconds in the early days, we managed to get it down to a couple of 100 milliseconds. That also included caching, which I'll get to in a bit. But really, that's the difference in the scalability side, is that variation in the two, and you can pick. So if you see one running hot, you can run another instance, or you can apply more resources to it. We found that really helpful. And platform as a service. So for us, as I was just alluding to, that's really useful. So in the early days, we were like every other cloud user. We built VMs and we stuck SQL Server on it and we deployed stuff. So once we realized that, the scale of what we're doing, the risk of that box failing was obviously high. So we started moving across to platform as a service as we could in the early days. So one of the early ones was SQL, which I absolutely loved because you can just slide it up and down and get as much compute as you need. And Redis was the other one for caching. So in the early days, we had a Redis server, just like everybody else, and we started using the Redis cache to improve our speed. And as I was saying before, patient lookup, it went from 1.2, 1.3 seconds down to a couple of 100 milliseconds, which with a nurse entering rows in, it's very valuable. So 368 releases, all this tech junk, what do we do with it? So first thing is we deployed to the rest of the state. Everyone wanted it because we were the ones in the electronic solution, everyone else was using paper and pen. So we ended up going all the way from Broome in the north to Albany in the south. I think there's about 15 odd clinics. So that's still used today. 1,500 registered users, give or take. Not all active, thank God. Statewide reporting, so not my side of the fence. We have a data team. And they would extract the data from the back end and report. So as far as I understand, we're the only state in Australia, so I'd like to brag about that can do centralised reporting. I think everyone else still has to do spreadsheets and do other things. So for us, the data guys did a fantastic job here, and there was hourly updates all the way up the chain about how many people went to a clinic. So literally within an hour of someone entering a clinic in Broome, anyone wanted to know that would know that fact. How many came through, how many positive, potentially positive. How many had travelled from, I don't know, was it South Africa at the moment? All those sorts of things, very valuable. So slicing and dicing data, very valuable for decisions and change. Contact tracing, another term we all know and love now. So that's another microservice, close contacts. So we would get that list and we provide the microservice that we deployed separately, and that allowed us to provide that function. So you're again in the clinic and you say, I'm a close contact of, or I was on flight X, then we've got that list of details, and then we can start linking cohorts together, the people on that flight or that were a close contact of that individual. Hotel quarantine, another wonderful term. So we extended the software to cover hotel quarantine. Unfortunately, working at Royal Perth or East Metro, we got stuck with that problem because we're the closest to the hotels. It kind of sucks. But anyway, so extended the product, and it's used in the hotels, or used to be used in the hotels. And that's, again, to manage the families, the patient families in the hotels, that sort of thing. And the airport. So at the airports, you had patients coming in, passengers coming in. Passengers coming in, potential patients, and print out the labels. So when you guys get a swab up your nose, we've got to put a label on the tube. So it's part of the function. We look you up, what's your name? Out comes the label on the tube and one on the form, and off it goes. So things like that, and just high volume printing there. So obviously that can't fail after 300 passengers get off a plane. So that's where we really actually had the surge thing. You could see all the load go up when a flight from Dubai landed. So that's really it. There's a variety of other microservices. That's sort of the big ones that I think you guys would understand or appreciate. So what was a typical day for us? So 8 o'clock in the morning, the clinic's open. And for the next 4 hours, we prayed nothing went wrong. iPads didn't go flat, you'd run the battery out there. Anyway, so anything broke, we had field guys out there fixing it, but we basically did nothing. We just sat and watched and prayed. And then around lunchtime, you guys have probably seen this on the TV, Chief Medical Officer, they have a National Health Cabinet. They'd all discuss and they'd decide what we learnt new. As you can see now with the Omicron one, they're learning new stuff all the time. You see on the ABC. It was the same back then. They would learn something new and they'd say, we need to know the temperature of the patient. We need to know the blood pressure of the patient. Whatever it was, they determine those things. And eventually, around lunchtime, 11:30, 2 o'clock, depending on our luck that day, we'd be notified, or I'd be notified that we had to change the application. So it took about an hour, trying to work out, can we do it? How long is it going to take? Work it out with the clinicians, what was acceptable, because we're changing an application. We'd have a team meeting, so the Telstra boys would dial in and we would hop on the call, and between us we'd carve up the work, explain what had to be done, and basically get started. And then, after that meeting, off we'd go. That would go on until the end of the day, or as long as it took, but usually 5 o'clock, if I was lucky, I could go home. I used to do the API, the back-end stuff, and the Telstra guys did the front. And if I'd finished in time, I could go home. Otherwise, we stayed till it was done, which, with kids is not fun. But anyway. So we continue on. So the next bit along, the clinics would shut at 8 p.m. So up until that point, we're developing, we're testing, wherever we are on that track, we're aiming for 8 p.m. Once all that's done, we're testing the hell out of that UAT. Once the clinic closes, we start our change, backup database, and start deploying code using our little DevOps pipelines. And I think, well, not to brag, I think we got it right every time. I don't think we ever had a bad night, thank God. And then we production verify. We test everything again. So we would test everything to make sure everything saved, everything worked as expected. All the features where we put in, everything previously in there was in there. It was very important because the clinic's opening at 8 o'clock. It was, and statewide, it's just, slightly nervous. And that was it. So we'd pack up by 10 or 11 o'clock usually, if we're lucky. Rarely past midnight, but quite late. And then do it again. And so we did that for about 6 months. Saturdays and Sundays not included. We're just watching Azure to make sure nothing, we didn't have any problems. So that was, our life for most of last year. So what did we learn? First thing is empower your team. So the thing I loved about this was the clarity of purpose. For the techs, if we wanted to do something, people got out of our way. It was fantastic. And because of the nature of what we're doing, it was, they let us make decisions. It was fantastic. We wanted to try Redis caching. We wanted to try SQL Server, that sort of stuff. It was, or play with elastic pools, all that stuff was possible. Solutions focused. So we always came, and that was the great clarity here, was we always had a problem given to us every day. And usually it was simple. Some days it was quite brutal, 10 or 15 extra database fields is not fun for the front end or the back end, but that's what it was. And as you heard me say before, automate where possible and have an Alex if you can. Minimum viable product. Again, the time constraint brings fantastic clarity. So we had, 6 or 8 hours of development. I don't know anywhere else I've heard of that being done. So for us, it was always, what can we safely do? What can we deploy as a minimum to meet what was expected of us and what had to be collected? And the separation of responsibilities. So again, let's say Alex's name once more. We had Alex, we had a few other people doing downtime forms. If the system was offline, we had paper equivalents for people to use. We had people for testing, we had people for communications to notify the hospitals what we're doing, if there are any issues, so on and so forth. Decision makers, and that sort of thing. And for the tech side, it was embrace PaaS. And the reason I say that is, for the SQL Server side, it was fantastic. We don't have to worry about patching. We don't have to worry about availability, that sort of stuff. Obviously, bear in mind your 9s for SLAs, but it's one less thing we didn't have to worry about. And redis caching, cache everything. We found that was implementing that for developers that haven't seen it before, they can be a bit nervous. Once you show them how it works and how to put in code, absolutely love it, because programmers always love fast code and bragging about it, as you've heard me do. So, and the slider, I love the slider. So with Elastic pools in SQL, I'm sure it exists in others, but for us, if the data team needs to do something, what we do is we crank the slider as far as we can, and that's when it's like, 15, 20, 30 grand a month, but we do it for about 5 minutes. So he can do his trunk and load, whatever he's got to do, and it does it in 3 minutes as opposed to 3 hours, and lock up the pool, and then we slide it back. So can't do that on premise. It's one thing I absolutely love about this, and just don't forget to swing it back. But yeah, once or twice, a few extra dollars, so yeah, just, yeah. And finally, some credit. So Microsoft, Telstra Pepper helped us out. Offshoot for our coffee, those of you that work in town. IGA for feeding us at night when we couldn't get home. And some of the staff there that worked with us. And that's it. Thank you very much for your time.